Okay, so just wanted to review where we left off. I, I remember mentioning in the last video that I would follow that one up with sort of an introduction to Redux Saga. So I made some changes to for us to be able to run asynchronous code. And now we'll be able to have a nice separation between pure and impure code in the backend application. So I just checked that in today. So go ahead and in your local repository, just do a git pull and let's see. Yeah, so I'm already up to date, but yeah, just do a git pull. I did there's quite a few changes there in here, and I can just walk you through how this works. So so let's just look at the source code here. This is where we left off here was this function, these method calls were not very realistic. In this example, I was just pretending like it was a synchronous function call. But in most cases, that's not going to be the case. We're going to be running asynchronous code here. So what I did was I introduced Redux Saga. So as a companion, think of it as like a companion to this reducer. There is a UPS Saga. One way to think of it is this file here is the pure code, and then in the Saga is where we put all the impure code. So the reason why this is impure code is I guess the definition of pure code is that for any given input you will always produce the same output. But when you're dealing with asynchronous function calls, like if you're doing stuff where you're doing a network call or even like writing or reading a file from the disk, you're not always guaranteed that for the input that you're going to always get the same output because an error can occur. You could have your disk could fail, or a network request could fail. So that pretty much means that it's not pure. So stuff like that is what Redux Saga is for. So also too, stuff like that's using time and date stuff to where you're using that in your calculation, where that's also by definition and impure. But anyways, what you do here is what I did in this example was I added a new method. So I can show you that in the user interface. So the method here is called readConfig. So this is kind of just just pretending like we're gonna be reading off the disk. So what it does is it dispatches this call action to read the config file. And the way reducers and sagas work, so that event will, or that action will make its way across to the server, and the way it flows is the action will go to all the sagas that you have, all the reducers that you have, and it will then go to the saga So so kind of the action kind of goes all over. It goes to all reducers, goes to all sagas. It's kind of just an action that anything can handle. So it's just kind of a rule, just with any action. But in this case, the saga is going to handle this action. So you can see that here. What I'm doing here is the saga is watching what I define here as a watch call, and what I'm doing is I am this while loop here is just watching for any time a call method a call method action is dispatched, and anytime I get a call method action, I'm going to come into here and I'm going to check to see if it's my object, and if it's the method that I am supporting. And if it is for me, I'm gonna there's pretty much like 3 things you need to do for these asynchronous calls. It's just good practice to the very first thing is to set the state to in progress. The second step is to do the asynchronous action. So here what I'm doing is I'm using, this is sort of this would probably be good to read up on, is ES6 generators. It's kind of Redux Saga kind of works hand in hand with the generators in ES6. So when you look at this code, while it's asynchronous, it's really like, it appears like it's not asynchronous. It appears like this actually is blocking until this actually blocks until this completes here. So that's what the generators do. So so what ends up happening is so in this function here, I'm kind of pretending like I'm reading off of the disk, but I'm really just, that's an asynchronous operation, and I'm just pretending like that. Instead of doing that, I'm just setting a timeout for 2 seconds and just kind of just faking that out just for this demonstration. So yeah, so after 2 seconds, just pretend that we got the result from the file, and what we do is we need to update the state of the action to complete. So if you remember from the last video, that there's an implicit watcher that's done on the state tree for methods when an action is received by the server. So it's really important for us in this case to we need to update that state in the tree so that the client can then be notified when this asynchronous action or this method request is finished. So yeah, so that's what we're doing in this case. In this case, I'm saying complete, and I'm setting the contents of the file. So I'll demo that for you so you can see that. What's really cool about this is about Redux Saga is testing. Is really when we're doing asynchronous code like this, it's really simple to test. And I wrote a test case just for this here, what we see here. So let's take a look at that. All right, so I have a UPS Saga, and I guess I should have renamed this to _spec, but yeah, I guess my next commit I'll have that fixed. But so anyways, so what you can do is you can what you could do is so in ES6 those functions those are those special functions with the star or asterisk, or those are generators. So with generators you could step through the generator. So what Redux Saga does is those take, and you know those calls you saw in that other file, you know they're yielding, and so so you could actually, what you can do is you could actually step through all that, and simulate. You could simulate the values that it would normally be getting if it was running in production mode. So so here what I'm doing is I'm just basically expecting this watch generator to be in this mode where it's taking call methods. If that's true, then I am dispatching an action to it, and then I'm expecting the next thing it's doing to be putting this method state to request in progress. And you can almost go line by line here with the actual saga here. So you can see that the very first thing is it's taking, and then the next thing it's doing is putting. So, and then the next thing is call. So we got a take, we got a put, and a call. So if you look over here, it's here's our take, here's our put, and then here's our call. So it kind of follows in line with what you're doing in the saga there. In this case, I don't think I needed to send the action here, but what I would recommend for when you're getting into writing test cases here, and it's gonna be, you're not gonna get this right the first time. It's gonna take several tries just to get the hang of this. But what I find myself doing a lot is just console logging this value here, because it really yeah, it's when you're first doing this stuff, you know, just print out where the generator is, and you know, that'll give you an idea, you know, if you're synced up, you know, with your step with what the generator is actually doing. So so I'd highly recommend that. But keep in mind though that every time you do this gen.next, you're actually iterating the generator to the next step. So that you know, you can get burned by that. So just be careful. But so yeah, that's the pretty much the gist of the Redux saga. So also too is the good thing about this is it not only allows us to test the case where everything's good, but it also allows us to test the case where there's a failure. So in that path there, if this function here readconfig, for example, if we if there's a network error, or I'm sorry, a disk error or something, or the file doesn't exist, we could, in that code, we could throw, and if we throw, we'll end up in this catch block here, and that's when we would put the method, we would set the error for the method state. But when we're writing our test cases, we can easily simulate that too. So here I'm kind of showing you where the generator I'm simulating that other edge case, where the error occurs. So so that's pretty much it with when you're doing these test cases for async functions. There's pretty much those three things that are important. You gotta set let the state tree know that you've got the request in its beginning. So here, and then either let the state tree know that it's completed or that there is an error. So that's it with the saga. So that's pretty much all there is to them. But hopefully it doesn't need to get any more complicated than it already is. So, but I'm going to go ahead and demo this for you so you can see it in action. So I have the same setup, the same three windows that I had in the last demo, same directory. So I'm going to start. I thought it was in the same directory, but. So let's start the server, and I think, yeah, I'm on different networks, so I have to change this IP address here. Where is it? I think I already did it. Yeah. So yeah, let me fix that. Where are you, IP address? Oh, okay. Oh, wow. Okay, yeah, I couldn't find that with all that. I'm sorry. So, yeah, all right. So 10.86. Okay, then I'm gonna start up this guy. Okay, so yeah, so here in the user interface, you'll see I added the new method call, and it's just a button. And so I'll go ahead and press that, and what that's going to do is it's going to run that asynchronous action. It's let's look at that code really quick so you can see, know what to expect. Okay, so essentially it's gonna grab that method call, and it's gonna run this reconfig, and then 2 seconds later we'll have our answer back with it will be Clint Eastwood. So let's do that. So and let's also open up the console here so we can see all this stuff happening. All right. So let's do reconfig. All right, so yeah, so there's about 2 seconds in between there. So we see the first thing that happened was we set it to in progress, and then the second thing that happened is now it's completed, and the rat is Clint Eastwood. So, and then if we look here, and the user interface, we got the in progress, and now we have it completed. So So this all together, everything that we've been doing, or everything that I'm showing here is essentially it's like a redistributed redistributed redux. That's kind of hard to say. Or we could think of it as like a remote redux. But it's pretty powerful to be able to have remote redux states and be able to watch their states. If you could imagine that, just everything that I've showed here, the server could actually be a client and run that same state, those same actions and reducers that the client is doing, and we could essentially, chain chain together, like, I don't know any reason why to do this, but we could actually have a totally distributed system here. So it is really, pretty much everything here has got the makings for, we could do pretty much anything, I would think. For the future, what we're going to be kind of mainly focusing on for future application development is on the back end. We're going to be writing. Oh, I'm sorry, wrong folder. It's in modules. But mainly we're going to be focusing on these modules here inside this modules folder. So if you could imagine, an action that, or a reducer that, that listens for, like a log to database action, and then what it would do is just, take whatever payload or whatever and just write it out to a database, or there could be a a reducer that's writing to a file, or a reducer that's sending emails or sending push notifications, or we could actually do things where one reducer kind of looks at various state trees and dispatches a list of actions. Let's say if the user wanted an email to occur, a push notification to occur, to write to the database, and do various things on various environmental conditions. Those would all be reducers. So most of our work is going to be for the future is going to be in writing those reducers and sagas and everything else. Hopefully the framework will be adequate enough for us to for us to do everything, and be able to write clean, testable code. So for the immediate future, with this framework, I kind of wanted there's some things that I need to do. Maybe you might have an opinion on, or I'm not sure if I like. I'm not sure if I like this state tree in the format that it is, where everything is underneath the mon objects. I mean, we could probably get away with just having it'd be a lot more simpler with the reducer composition if we just had each one of these guys just be kind of like top level objects, and not have like a parent container, and have them just be, whatever is at the top level is the mon object, that the protocol will refer to. So that might be a change. One other thing that I need to do and I'm sure you may have seen this, is these state changes. They're not, the state is updating for it seems like it's updating when it shouldn't be updating. So the point with that is that these reducers are let me show you, not that one, but like this one. So the rule with Redux is you never ever modify the state that comes in, and that you always kind of work off a copy. And the reason being is that after all the reducers are called, I think internally inside of Redux code they compare they compare the two states before and after, and if they are different, then your subscription gets called that it changed. So anyways, I've been noticing just with playing around with this is that yeah, I've just been seeing the state change, but I don't think it should be changing. So what I like to, in all the other times I've used Redux, I've always used a library called Immutable, and that I've never had any problems with the states updating, when they shouldn't be updating. So I am planning on having a demo where this is just using Immutable. It's for me, it seems like it's just easier to understand Immutable than it is to use the new JavaScript functions, especially for our objects that are when they got they nested several levels deep, and I get kind of confused by using that. So it's a lot simpler, I think, to use Immutable. The only reason I'm using these JavaScript functions is because that watcher that I'm using on the state tree does not work if my state tree is an immutable JS object. It only works if it's a pure JavaScript object. So yeah. So and since I pretty much that subscription code I've kind of had to do a little bit of work to tie the subscription to the sockets. It wouldn't be much more work for me to just take that, take it over altogether, because it's just all we're doing is watching the state tree, and when it changes, and just iterating through all our subscriptions and seeing, doing a comparison, and that to me seems like it would be a pretty simple change. But so that's pretty much what I'd like to do in the near future. But so yeah, but that should probably wrap it up with with the framework. Hopefully this is hopefully this will be adequate for us. So we have an opportunity now because we're starting from a clean slate. So this is all new development. So if there's anything that we could do to we'd certainly, now is the time to fix things that are not right. So because everything's this will be kind of the framework. So yeah. So I look forward to any input that you have, and yeah, if you have any questions, just email me, and we'll talk more about this.